everyone. Thank you for joining us to talk about building trust into digital experiences with decentralized identities. My name is Ankur Patel. I'm a program manager with the identity team at Microsoft. Our team has been doing an incubation effort around decentralized identities for the last 2 years or so, and we're thrilled to share with you some of our first set of open source code around it to allow us to do a flow end to end. Traditionally, when we go and talk about why we need identity systems, that's been a key question around why decentralized identity. So we'll cover that first. Then we talk about how does it work, give you a quick demo, and then we can look at some code under the hood to see how you can go build such experiences. And finally, we'll close with what's next on how to get involved. Let's get started. Today, when we go and talk to users about their identity, most people think about their identity as a username and a password. However, we know it's a lot more than that. It is, in fact, thing we do on our everyday lives. The problem with this picture is it looks a lot more accurate if it's depicted like this, right? And we have evidence of this in everyday headlines of personal data breaches or enterprises spending time and effort on audit and governance. Now, compared to that, for more than 1 billion people on this planet, it's a first world luxury to even have a digital identity to begin with. The core issue here is that all of these identities are strung to a centralized account. And therefore, if that centralized account turns off, all of our data and our identity can disappear. So we've been talking to our customers on what might it look like? What are some of the core needs that such a centralized identity system is unable to address? We all have empathy for our challenges around privacy and control over our own data. As in our very first column around individuals when we talk to normal consumers. When we talk to organizations, they trust Azure Active Directory, more than 19.5 million businesses do. But the core question they ask is, how do I verify who is in control of that credential? And that is a difficult problem to solve, right? Because the trust is in the domain. How do you go and verify that beyond the domain? And then we talk about collaborate with everyone. Many businesses have set up federations as a way to collaborate with each other, right? We are able to invite each other on SharePoint or Teams. That works when your IT team has gone and set up sharing between those entities. How do you do it at scale? How are we able to collaborate with everyone, like 50,000 businesses? Today, hospitals need to share records with each other all over the world. How do you do that without having to wait for individual IT systems to get set up? Finally, there is emerging laws around GDPR, General Data Protection, or as previously described, regulations around know your customer or anti-money laundering in financial case. We've all done a lot of work to protect that data, but how might we go farther in ensuring that the user has insight into it? So for example, for GDPR, how many of us remember how many websites we've gone to since, let's say, May 1st? I'm recording this on May 11th. In 10 days, I can't even keep track of all the websites and applications I've gone to. So how might we empower users and businesses to have greater transparency and control? And then finally, a category on governments. And here governments are non-government agencies as well, right? Such as UN, when we go talk about a refugee being able to request asylum or seek aid, it wouldn't be appropriate to say, get an account from Microsoft or Facebook or Google or Twitter to do such a thing. You need an identity that's truly under your control. We believe this is a key step towards social and financial inclusion for everyone. How do we ensure such a thing? So our thesis has been that we believe the user needs to be also recognized as a data controller in addition to centralized identity systems. So this was our North Star statement for almost 2 years, and now we believe this could be a product reality. We believe that each of us needs a digital identity that we own and control, one which we can securely store all the permissions and scopes that go with it under our control. This self-owned identity has to integrate with our existing internet. We can't wait for a whole new internet to be written. So part of this work has been figuring out how do we ensure compatibility with existing open standards so that we don't have to wait for these new promises around verifiability and privacy until a whole new internet is written. So let me show you how that could work. Let's dive into a demo. So here's a student who is being invited to receive a student ID card. Alice attends Contos University. Her university has said, if you scan this QR code, we will issue a digital student ID card. So when she scans this QR code, she has an app that is registered to handle such a request. In this case, it happens to be a Microsoft Authenticator, but again, based on open standards, so she could use her preferred wallet. Authenticator then presents her with a request like a student ID card being presented, much like a normal coupon flow or travel card that you can do to get on an airline, for example. Except in this case, she's been asked to say, sign into Contos University to prove that you're a student here. So she clicks on that link. She goes on to provide her normal username and password. Now, if you didn't have that relationship, you can imagine she would have been invited to come do proofing in person, right? Come by the registrar's office and then you receive it. But in this case, she had a username and password. So since she presented it, now she's getting a signed request from the university saying, would you like to accept this card? So she does and secures it using her biometrics, in this case, a fingerprint, but it could have been a Face ID or a PIN on a feature phone. Upon securing such a card in her wallet, she can now look at some of the details, such as where she can use it, what is the metadata that was signed and attested to by the university. You can notice some of these dates are fictitious in here for the purposes of demo. But the university gets to sign it and provide cryptographic evidence of these being genuine. The user, in this case Alice, also ends up with a receipt that says, here's a timestamp of when this credential was issued. And this is something that nobody can take away from her because it is locally under her control. She goes to the Fabricam bookstore and she notices, hey, they can give me a bookstore discount if I can verify that I'm a student. So instead of a round trip email code, and if that email disappears, are showed as our student eligibility status. But in this case, even as an alumni, she can present a verified credential response. The flow is very similar to receiving a card. Authenticator now receives a request that says Fabricam Bookstore wants to verify that she's a student, in this case, Contos University. And here's the reason why. If she chooses to allow that, again, she authorizes it with her fingerprint or biometric or a PIN. Fabricam Bookstore is now able to verify that not only is she the one who can present it, but that Contos University will attest that she's a student. Furthermore, she gets this receipt that says at this date and time, I have shared this information. So compare that to our normal web experience. Now we have a receipt of every interaction that we do around where our data is shared, for what purpose it's shared, etc., under our control. Furthermore, we can revoke it if we choose to. So now if she chooses to revoke it, she now ends up with a receipt that says not only when whom she shared it with and when it was revoked. Now, the same experience can be possible with multiple cards. So here she has another card which says she's a project management professional as attested by Graphic Design Institute. When she goes to Bellows College for some advanced project management training, Bellows College can request 2 credentials just the same way as a bookstore requested 1. And for Alice, the gesture is the same. It's just doing an approval with her fingerprint or biometric, and the Bellows College is able to verify this instantly. Imagine what this experience is compared to what we do today. So how does all this work? It's about empowering users to own and control their own identity. Therefore, it has to be based on open standards. Our mental model is to think about giving users software that allows them to own and control their own identity. So the very first piece of technology is a user agent. That's what a Microsoft Authenticator is. It's an instance of it, where it's storing cryptographic keys and enabling Alice to secure it using her biometric or PIN. The second key capability is an identity hub, where permissions and consent are stored typically in a system. In this case, it's stored locally on her phone. It can optionally sync to the cloud if she chooses to. Now, if all of this data is stored locally, how does anybody know that these keys belong to Alice? So that's what universal resolver and a directory system are typically used for. In a decentralized system, because nobody owns and controls a single directory, you can use things like a blockchain or distributed ledger systems. This work is based on W3C standards around decentralized identifiers. Alice can now present such credentials signed with her blue key, where the blue key is the private key that's doing the signing, and the transparent key with the outline, the blue key, is published to a distributed ledger system, so that when another person, application, or device receives such a verifiable credential, they will be able to verify that only Alice could have presented it, and only the issuer could have issued such an attestation. The current state of a lot of these standards are now moving into working implementations along with the published standards for the key bedrocks around verifiable credentials and decentralized identifiers. We would love for you to join, collaborate, and contribute to this work through Decentralized Identity Foundation or W3C as you best see fit. So now let's look at some code under the hood to show you how you can go about enabling such a flow. The very first thing we should think about is how Contoso University issued such a credential. So imagine if you are such an administrator, you would have configured your key vault. In our case, it's Azure Key Vault, but it could be an HSM or whatever you best see fit. You have to bind such a private key with a DNS domain or something that the world would be able to say, this private key belongs to you as Contoso, the university, for example. And then the DID needs to be registered on a distributed ledger system so that everybody can find it. So let's take a look at some of those steps. Here's a sample document which shows you how you can publish a well-known DID document to your website and have a verifiable credential signing it in order to have users and or applications who receive signed credentials from such a DID know that only you as Contoso University could have issued such a credential. Then the next thing you can do is configure those credentials, the look and feel of the card, if you will, right? So you can customize what the title of your credential is. You can state your brand name. You can control your brand colors, your logo, etc. But you also get to control the metadata based on the verifiable credential format around what a student ID number is, date of issuance or expiry, the profile picture if you like, etc. And finally, we need to provide a deterministic way for applications like Authenticator to know what input credentials or proofs do we need to provide in order to receive such a credential. This includes credential claims properties like how long is this good for, how are you signing it. For the credential flow, you can request a user to present self-issued information like, I don't know, their font color or size, etc., font size, etc. But you could also ask them to present verifiable credentials or even traditional ID tokens. Like in this case, Contoso University can configure it to say sign in with a ID token, identity token, just like a Java Web Token based on JWTs, which says we need to know a signed claim about your student ID, your given name, and your family name. Now the student would have received that request as a QR code, as you saw in the demo. And when Authenticator received such a request, it manifested itself as a normal credential flow. So all this stuff is happening under the hood. As a result of that sign-in button now, the user knows to look at this OpenID request, or in this case, the user agent knows to look at the OpenID request and respond to it, just like a normal ID request that you would expect. Most developers are familiar with doing OpenID request flows. The other key thing here is that contract that we just configured, right? This is at this website. Now, this is likely to change as a protocol as the community develops interoperability. But today, in our initial offer, we think it's a URL on the internet. Upon receiving such a request, you can check that this is a genuine request signed with the correct set of signatures by the issuer, in this case, Contoso University. And then the genuine request is presented to the user, in this case, Alice, to Authenticator. She signs in using her normal credentials. She gets a normal ID web token being issued to it upon authorizing such a request, right? So in this case, it tells you all the metadata that's requested in the protocol. She has a good request, which now Authenticator says, this meets the contract requirements. Let's go ahead and present the user the opportunity to accept such a credential. She can now approve it with a biometric. Doing that gesture actually generates a private key for Alice, which is secured in a secure enclave, and the public key is published to a distributed ledger. In this case, it's called ION. And that ION network matches the user's ID, and it shows who the issuer's DID was. This all follows W3C's Decentralized Identifier credential standard, and the credential payload is a verifiable credential here being presented based on W3C standard again. Finally, the last check is it matches the credential signature of the issuer's DID. All of this happens under the hood, and the only experience the student had was approving a card for use. Now she's accepted this credential. She can use it at the bookstore, as we saw, which is just another request. By now, you know what that request looks like. But here's how Fabricam Bookstore would have requested such a credential. This is, again, using existing standards around OpenID. And here, the bookstore is making a normal ID token request, or a OpenID request, I should say, for a verifiable credential of type student ID, and provides a reason as to why they're requesting such a thing. The other key part is that it's signed by the Fabric and Bookstore's DID itself, so Alice would know that this is a genuine request. Upon approving it, the response is then sent over to the bookstore, and Fabric and Bookstore is able to match the person presenting this credential and the DID of the subject to be the same. Therefore, only Alice would have presented this, which is significantly better than possession of a username and password. Finally, she gets a discount. The last key technology here is a signed signature. So when the verifier receives such a thing, it results in a receipt, which is a signed receipt, which Alice can now have under her control. And the last part we had looked in our demo was just like Fabric and Bookstore requested one credential, they could have requested multiple credentials like Fellows College did. So that's a quick overview of concepts that are involved in doing this key flow. Let's talk about what are some of the next steps on how you can get involved. What we just demonstrated is some of our progress around demonstrating compatibility with existing internet, like based on open standards such as OpenID and verifiable credentials and decentralized identifiers to do registration, key management, revocation. We're open sourcing our initial repositories around this work at this address, and we'd love for you to check it out and give us feedback. There's much more work here to be done, and we look forward to sharing that with you in the coming weeks and months. The second key part we realized when we started this work was how do we have a scalable directory system? So in our case, we have adopted a standard developed in Decentralized Identity Foundation called Sidetree Protocol and implemented in top of Bitcoin called ION. It's an open source project, and we are thrilled to participate in it and now announce operating a node around this particular ledger system. We would love to partner with you in operating nodes of this network. This is a truly decentralized, permissionless system, and we can't wait to partner with you on it. The final key piece is working with Decentralized Identity Foundation. That community has grown many folds over the past several months with lots of diverse participants, some from large brands to some of the more emergent ones, across a different set of variety of verticals. There are two key new initiatives they are starting that we're particularly thrilled about, as we believe these are two key bedrock capabilities that such a stack will need. One around zero knowledge proof, so that we can ensure privacy preserving ways of presenting things like age proof without having to disclose your birth date, for example. And the other key one is self-owned key recovery, so that we can switch phones and recover these credentials that were issued to us without having to go through a lot of onerous challenges, if you will. So these are the three key things that we would love to partner with you on, and look forward to the community's feedback. A key place to get started from for our work is by scanning this QR code, and we sincerely hope we can help towards helping each of us own and control our own identity. Thank you very much. A key thing here is we're looking forward to partnering with you on this new open source initiative to make sure that each of us can own and control our own identity. Thank you very much.